链接给他们。链接是咋生成的呀？
它这里会有一个 view。
我等一下，我要站稳，我看这儿行不行？我能这么说吗？也能这么？好奇怪哦！我应该站这儿。
对，是的。
但这根线它也是这么长。其实所有东西应该收到后面去，这就不应该出现了，因为这个在直播画面里感觉会有点干扰。对。没事，我就先站这儿吧。
传信号，现在还在传信号，等一下。
对的。我操，还有延迟。
对。有延迟，因为这个是 YouTube 的画面 ，YouTube 会延迟一下。
对，
画面里我还在。
对，是的。
不发。
没事，只要思考，没事。
你这个 OBS 缩小就可以了。
对，就完全不用管 OBS 了，应该。
是的，因为现在根本不需要。
对，只是为了开始直播。你看一下这些线啥。然后你。对，这就有了，可以了。
直接发创新。
YouTube 让他们分享看。
这两个没有什么延迟吧？
不太确定。这个他们能看到这个同步延迟，跟我们一起同步延迟，都还好，声音还有那个人像什么的都同步延迟，都还好。没事，你做。我看这个就行，我也不是看不了。
对，我刚才问的就是这个原因。想看这个或者因为看这个不是很清楚这方面的。
没事，我看这个。要翻墙看。
看看有。要不你先预扫一个，先扫标记点。对，等一下我们节省时间，我们直接就开始了。 现在已经开始了。
已经开始了。
对，现在已经开始了。哇，这也太黑了，必须打光。
我操，这个还虚焦啊！这个，你看，虚焦有点厉害。我看一下后面这个能看清楚吗？这其实也能看清楚的。就可能有个人得在那里看着相机。如果我要拍这个的话，我应该定焦定在这儿。对。然后这个后面就不要对焦嘛。等一下，等到那个真的要操作的时候，可能就放在后面。我操，他看不清楚，其实啊，对，前面能看清楚。对，到时候还是以投屏的方式吧。这个只是一个真的在这里看不清楚的。行，你先扫这个，然后等一下我们直接开始。好，先建个背景平面啥的。然后今天我们就直接开始了。没事，等一下你可能得调一下，因为等它开始扫描的时候，可能就得对这个。
0.3吗？
没有，0.5就好了，我们只是走个流程而已，没有什么其他特别。
现在扫描吗？
等一下，还没开始，马上再调。
它是要对到后面是吗？
没有，现在我们扫描的话，我们还是对前面。等一下，我们等那个这边就是结束了扫描以后，再对这个大屏幕。就你得看着，对你得看着，今天你得看着，对。 就行了，到时候就不用看了。OK， 那开始。等，没有，我跟马丹说开始，可以开始了吗？
现在不就开始了？
啊，行 ，OK。Okay, so good morning everyone. Today we will do 3D scanning of this industrial part, and then we will make the live stream reverse engineering of this industrial part. So firstly, I will introduce my colleague called Ma Ruinan. He will be today's engineer to scan the object and do the reverse engineering with the QUICKSURFACE software. And I will give you some comments, and if you have some review or any questions, please feel free to text and I will give you the answer. So we will go to the first part. We will start the scanning with the blue laser and marker mode, and let's get started. So we have scanned the markers, so we started scanning the industrial part directly. We are using the 0.5 resolution to scan this industrial part, and I will scan the front side first. Slowly rotate the turntable so that every angle of this industrial part can be scanned. With the blue laser marker mode, we can achieve the highest accuracy of up to 0.04 millimeter. During the scanning, we can observe the screen and the PC that you scan. So you can see we have opened the color map mode, and we are trying to make every area and every angle turning green, because we need a green color to reflect the high quality data that are enough to be processed to generate a mesh model. So when all the part turning green, we can stop the scanning, and then we can process to finish. And then we can create a project file. So at this step, we can save the APJ file, which is the APJ format, because we need to scan the data twice. The first time we scan the front data, and the second time we scan the back data, so that we can combine the two models together based on the common markers on the object. So today we're gonna use the front part as a demo, and then we will to show you how to align the two data together. 然后你放一下那个录屏。We just repeated the previous process, and then we got a back data. So we save the project file and import the APJ file with the marker stitching function. And then we import the front part and the back part to choose the common markers on that industrial part, just to find at least 3 pairs of the common markers, so that we can align the models together. So you can see at the right side, we can combine the model and then click apply. The software will automatically do the combination, and then we can get a complete file. Choose the wrapping, and then we can generate a mesh model. So all the things can be done within the 3DeVOK scanning software, and then the STL file will be exported and into the third-party software called the QUICKSURFACE. So we will do the next step, the reverse engineering. 这个可以过了。就稍微做一下保存。然后你就直接 QS。Okay, after we exported the STL file, we can open the QUICKSURFACE software and then import the STL file that you have scanned. then we can do the reverse engineer. So first we must observe the industrial part that we got. So first step is to extract the primitives. Yeah. To observe this industrial part, we need to find where is the base, because the base is the primary element that for us to establish a reference plane so that we can give the industrial part a correct coordinate. Click the extract primitives, and then we can select a certain part to create a base. Just create a plane so that we can give them a reference plane to create the x, y, and z axis. This is the sensitivity, which gives us the certain area, give you the enough reference to create a reference plane. And then we continue to create a third element, adjust the sensitivity to create a fit plane. So we got the 3 elements, which is enough for us to coordinate to do the alignment. Okay, the next step is to do the alignment. So the primary feature, we must choose the base, which is most important part for us, and choose the plane 3 that we just established. And then to fit in the secondary feature and the tertiary feature so that we can create a correct coordinate based on this industrial part. If the coordinate is upside down, we can click the flip function to adjust it to make the z axis on the top. Okay, so we have finished coordinating the system. So next step, we can continue to do the reverse engineering. So the first step is to create a 2D sketch. The 2D sketch helps us to stimulate a contour of the industrial part. So you can observe, you can drag the plane. So we must find the most comprehensive plane so that we can give the most complete the outline of the industrial part. 哦，可以的。怎么了这里？哦，它那个 Z 轴反。We need to adjust the z-axis. We need to correct the direction so that we can give the coordinate very correct. So we just adjusted the z-axis. So we jump to the next step to create a 2D sketch. Jump in the 2D sketch section, so you can see a simulation of the outline has been drawn by the software. So at this step, we need to left-click the mouse and to press the Shift key to choose the stimulation line for the industrial part, so that the software can automatically create the line and extract the line. With this method, we don't need to draw the line by ourselves, but automatically done by the software. This is a very quick and efficient method for us to capture the outline quickly. So here we can join the two lines together, and we can make some constraints for this industrial part to make the line vertical or horizontal. Press the Control key and to join these two lines together, and we can also create a round, which can customize its diameter. So repeat these steps for another corner to create a round. Repeat the above steps and to design the parameter by yourself. We are trying to make those parameters more like a natural number. To adjust these parameters can help us to get close to the exact size of this industrial part. We need to create an arc here and choose 2 points to stimulate some part of the arc. Manually drag those arcs to fit in the point cloud projection of the 2D sketch. Or manually adjust the parameter or the diameter of this round, of this circle, so that we can fit the actual size of this industrial part. We need to extend this line to make all the above part to fit in the size. We need to make an extended part to insert into the industrial part so that the above part can be established completely. When we finish the 2D sketch of the upper part, we can continue to draw the bottom part. Just repeat the above steps and to go to the find the perfect projection to show the entire outline, and then to enter the 2D sketch drawing. So firstly, we can draw the line. With left click the mouse and click the shift button. Join them together and repeat the above steps. Sometimes we can adjust the point on the line so that we can fit them more perfect. We choose the curve function to stimulate and follow the 2D projection done by the software, so that we can create a 2D sketch following the shape of this industrial part. We can also change the tools so that we can draw the line or draw the curve. Continue to draw the curve. We can manually add some control points of this curve so that we can make them make these curves more precise by slowly dragging those control points to subtly adjust the shape to make them more accurate. In this case, we observe some points do not fit together. So we can use the trim tool to remove the excessive line to join this curve into a complete curve. And then we can give them some constraints to make them tangent. If we finish the drawing of the 2D sketch, we can click the Finish button to stop drawing. And make sure all the curves are joined together and it's a completely closed curve. Slightly adjust the curve so to make them more smooth and make them close. Okay, we have finished the drawing of the lower part. So we have a 2D sketches of the lower part and the upper part. So the next step, we need to extrude the both parts. We can drag the 2D sketch and then to fit the surface of the actual STL file. And we will do the same at this part. This can help us efficiently fit the actual faces of the STL files. We can get an accurate file. Drag the body again and to make them join together. So we have just finished the exclusion, and then we need to combine the two parts together to make them become a complete CAD file. Cool. Okay. In this case, we can also return to the 2D sketch stage to subtly adjust some points on the sketch, so that we can make the this extrusion more fit in the actual surface.差不多就得了，我们走一遍这个流程就行。对。So after the adjustment, we can combine the two solids together. 哦，对，还要挖个洞。So we observe there is 4 holes on the industrial part. So at this case, we need to have to create 4 feed cylinders, so that we can dig the holes and remove the solids on the bottom part. To do the cut function, and then we need to extend the cylinder beyond its actual surface, so that we can remove all the unnecessary part. We need to unite the diameter of the 4 holes because we need a actual size. Because the actual size will be united in those CAD files. So let's use the cut function. Cut function to remove those cylinder and to dig a hole at the bottom part.它现在下面不是实体了。下面不是实体。为啥？就没闭合是吧？ Okay. Yeah. Why we cannot cut those cylinders? Because we observed that we didn't create a closed curve just now. So we must check every point to remove the unnecessary part and make sure all the lines and the point be joined together. Yeah, we require the solid so that we can cut the 4 cylinders. So you can see here we have created the 4 holes. Okay, the final step is to combine the bottom part and the upper part together. Okay, so we to hide the meshes and the sketches, you can observe this is a complete CAD file created by the reverse engineering, and we just show the whole process of this modeling of this industrial part. Yeah. Okay, so final step, you can do the accuracy analysis. So we can set the tolerance up to 0.5 millimeters, so you can see the most of the part will become green, which shows the great tolerance. 可以，非常好 ，great. Yeah. Okay, so this will be the CAD file we just created, and then we can 调一下那个保存类型，不对，QSF 不对，save， 左上角那个 QS， 左上角这里有个 export model。export has scan data. 你看一下 Yeah, we need to create a STV file which belong to the CAD file for the real production. 不对 STV 第一个 STV 对。So this is a whole scanning to reverse engineering procedure to how to change a real model from STL to STP, which can be used to the real production or to create an actual size of this industrial part. So this will be today's live streaming. Do you have any questions?